the recording. All right, so welcome everybody to second session of this year Rebase. I'm super happy that I can introduce Tudor, Alex, and Oscar, who are going to join the discussion about moldable knowledge. I saw Tudor, we had him speaking at Carrion, which was also co-located with eCoop 2 years ago in London, and he showed like the best idea that I think everyone would like to have at some point. So I'm really looking forward to see what was the progress on it and all the live demos that he has prepared. Then with Alex is a professor at the University of Chile, and I first saw his work about the agile visualization. I was a PhD student at the University of Nice, and he came over to show us how to visualize code, and it was like a magician. It's really cool, and I guess this is highly correlated to the work of Tudor. And then finally we have Oscar Nierstrasz, who is the professor at the University of Bern. He got the Dal Nygaard Prize, which is actually awarded at eCoop that the Rebase is associated with. And he's the one who kind of connects the two before, because he published with both Tudor and Alex before. And the work that I've been following from Oscar was the work on traits, which are quite influential and made it into other programming languages. So it's really cool to have all of the three together. And I'm excited about the work on on moldable knowledge. So without any further ado, the floor is yours. As for the questions, just write them in the chat. I will, if I see the fit, I will try to interrupt Tudor and read them out loud. Otherwise, we can take them afterwards.
Thank you. And my name is Tudor Girba, and I'm the CEO of Think. At Think, Think is a company at which we're focused on making the inside of software systems explainable. That's our long-term goal, and everything we do serves that goal. And to this end, we contribute both technology and techniques for humans, for basically enabling humans to relate to the inside of software systems more comfortably than they do it today. And the overarching set of techniques goes under the name of moldable development. And we've shown moldable development over the last couple of years in several different ways. And some of the application areas are quite, so the application areas are quite broad in moldable development. And it goes from how we develop ourselves, but also how we relate to systems that exist already. So what people denote as legacy systems. And here are, for example, a couple of examples of such scenarios. So here we have a React Native application. And if we inspect this one, so here on the left-hand side, we have what we call a playground. And here we have a couple of snippets. And in this case, I have inspected a file reference pointing to this root path over here. And in this case, this is an application called Zooniverse. It's a React Native application. And we can see here it has the structure of a typical application. We have sources over here. We also have package.json. And I like to show this package.json kind of demo because it exemplifies the core idea of moldable development. So let's take a look at it. So in a package.json, you would typically see kinds of dependencies like this. And it's interesting, like these dependencies, right? I can skim through them in one shot, right? Just with my eyes. And it looks reasonably comfortable. I can read this reasonably well, especially if I have some sort of syntax highlighting. But if I have a tiny problem that is slightly more than just going through these ones one by one, it starts to become a little bit cumbersome. For example, here we like to ask people, well, how many non-React Native dependencies do you have? So you have here all of these dependencies, and the question is, okay, when you know that you're already based on some core framework, you don't really care about the technology that comes or the dependencies that come with that core framework. So what are the other kinds of dependencies, right? And all of a sudden here, we need to manipulate this information in some form. And of course, we could kind of see, okay, here, this is one, this is another one, yet another one. And then, of course, but the React Native, these ones we don't care. But so they are also not in order, which makes it a little bit, makes the problem a little difficult. So if we read right? The problem is not particularly comfortable. But what if you don't read it? So in this case, say, I'm going to open here a little object playground. So in this case, I'm going to have access to this object over here, which points to a file reference. So I have here self will point to this file reference. And if I say content to this file over here, and I'm executing this, I will get a string back. And because now I have a file, right, I can simply say, because I have a parser for JSON, I can simply say something like this. And now what I get here is I get a dictionary all of a sudden. It's no longer it's no longer just text. Now I have the data structure underneath, right? Because this is JSON. So I have here dependencies. And now, of course, we can just quickly say, I can see here that there's a key value, which is called dependencies. So I can say, okay, give me those things that are dependencies. And I can see, okay, I have 40 of them in total. And if I just take the associations, which is just a key value pair, then right, I will now have an array, which means that I can now select it. And I will be selecting it by the key that begins with React Native. And so, and now, of course, I'll get the React Native dependencies. And if I don't want those, I will be rejecting these. And I have like 19 kinds of problems. And so this is, that's the idea of moldable development. The idea here is every time I have a problem, I'm going to ask myself, what is the most interesting tool that would exhibit that problem? Because everything about software is data, and data doesn't have a shape, doesn't have a specific shape. But we as humans, we need a specific shape to reason about anything. And as a consequence, the way a problem looks, the way a software problem looks, is fundamental, is not something that is optional. Which means that we need to take specific care about how that problem looks like for us. And very often, because software is so highly contextual, we cannot predict classes. We cannot predict specific problems people will have. We can only predict classes of problems. Because we can only predict classes of problems, it means that we can only build, we only know what tools is interested in after we know the question. But because we only know the question at the very late, like during development, it means that the tools have to be created during development. And that's the very core idea of moldable development. Now, the other thing to consider here is what's the name of this tool? And so because it looks like a notebook over here, then it looks like a file browser, then it looks like an editor, then it looks like some sort of a query tool, and then I have some other inspector over there. So one of the essences of moldable development is that we think that the environment is not a set of tools, but it's a set of operators. It is a language made out of interactive and visual operators that can be combined in many different ways, depending on what people need exactly when they need it. So this is one simple example over here, but we can go further here. So for example, React Native is implemented in JavaScript. People say, well, JavaScript is a dynamic language, which of course it is. But if you look at React, right? React is like its own little world on top of JavaScript. And if you do not understand, if you don't look at the code through a React lens, you will basically miss most of the points, most of the problems that are exhibited in the code. So, for example, one of the issues here, like when we talk about React, so here I've built a model I took all those sources and I parsed those and I built a model that gives me a graph. And then on top of it, I did it on the JavaScript level, but then on top of it, I also took into account the specifics of the technology. So here, for example, we have components. So what is a component? A component is so here I'm looking at a component and I can see here, okay, this is instruction view, which depends on some other things like shape instruction view. For example, in this, it's a specific syntax, or not specific, specific kind of like a DSL. And then in there, we can see the dependencies between these components. Now, this is particularly interesting because during development, we actually got to a problem that appears to be reasonably common while working with React. And that is, you have these components and it's quite easy for them to start depending on each other and then ending up with circular dependencies that pose problem at runtime. And you only find those things at runtime when the problem exists. And it's difficult to debug. So the alternative, of course, here is that, well, given that these types of dependencies are actually quite hard-coded, so we can see when one entity depends on another entity, quite specifically here, we can also do something more. So here I have all of these React components, all this group in which I have 53 of them. And so then we took a bit of time and then we built this view. And so now this view gives me a better understanding of exactly this problem. How do these components relate to one another? So if I look, for example, at the render button over here, I can see, okay, it is defined over here, but then it returns button, which means that there's going to be a dependencies from rendered button to button, and so on. And so with this view, for example, we can quickly find where circular dependencies are without actually getting into the trouble at runtime. Now, the reason this is interesting, or for this specific talk, is because React Native React is a reasonably popular UI framework, and this is a reasonably often occurring problem. Yet there aren't real tools that deal with this, and that is a surprising fact. And so one of the hints one of the points we want to make here is that tools used to be expensive, but they are no longer. They don't have to be, and they aren't anymore. And so when the cost of tools decreased dramatically, we have a chance of tackling very specific and very narrow contexts much more effectively in an economically effective fashion. So, and the other thing we've seen here is that, again, like if we're going to look at this code over here, it's just with JavaScript perspective of just JavaScript and function calls and so on, we would simply not see any of these problems. Like this problem will be completely invisible. And so that's the idea. This idea is that it doesn't matter how much you think you know from the outside about a system. It's always the context of the system that should dictate what is important and what is needed from a tooling perspective. And we see this kind of problem appearing all the time. So here's another example. In this case, we have Ruby on Rails. So I have a case here, an open source case study. And then here we built a Ruby on Rails specific model. And because we have Ruby on Rails specific model, we can start to have things like this. So here we have, in Ruby on Rails, you can have active records. So here I'm inspecting the active record superclass that actually comes with Ruby on Rails. And what active records offers you is this connection, this magic connection to the database. And so based on the schema definition, like some magic attributes will be inserted into the class. That subclass is active records. And then if you do not know, so in order to reason about the dependencies of these objects, you'll have to actually look at both the schema and the source code in Ruby. And so so here we have a situation. So here we're looking at all the subclasses of active record. And when I look at the hierarchy, I can see, okay, here's the hierarchy. So these are all those things that actually have some sort of mapping to the database. And if I click on one of those, I'm going to see, okay, this is actually a class. I can see the source code of it. I can see, okay, look, this one inherits from active record. And, but I can also see, okay, it's actually defined here. This is the table source. That's the definition of the same class. So the corresponding table defined for this specific class, right? So I can, in one click, I can flip between the two. But even more interesting are these kinds of things. So now we can say, let's see if we find one with more interesting. Oh, we don't find it. Okay, so yeah, we don't find it here. But so in this case, you have attributes which are like this. So this is at the redirected URI, and then we have these attributes that actually come from the database. And so based on that, we can. So here, this one is going to come from the database, and this one comes from the source code. So again, like this case too is without correlating these pieces of information that are specific to the technology, it's simply hard to go and find the relevant information that you actually need when you're programming against this. And the other thing that we have noticed here is that the more specific we go, the cheaper it is to build the technology. So generic problems are very hard. So finding all dependencies in general is very hard. Finding all acyclic dependencies, taking all possible reflection into account, that's a very hard problem. But when you actually go and look at the specific of the framework that you're actually looking at, and you know the kind of problem that you're up against, and all of a sudden the problem actually decreases in cost. Okay, so the core idea of moldable development is simply this, that we basically want to apply the scientific method for absolutely every single development problem we have. We start with a hypothesis, we apply an analysis, we get some results, and if we're confident, then we act. It's very important that we act. If you're not, then we repeat. So that's the scientific method. There's nothing new here. However, given that with software, as I said, there is no way for us to predict specific problems people will have. We won't know these questions. We will know classes of questions, but not specific questions. Because of this, it is very likely that for a specific question, there is no tool available. And it's so important that at this moment in time, it's exactly at that point, we should stop and ask ourselves, do I have the right analysis? And if I don't have the right analysis, I should go and build it. And that's the whole thing. And what's interesting about this is that it's actually much more practical than people think. So there is a learning curve as to how to do it, because it's very easy for people. So for us to simply fall back to just manually going through the weeds of software in front of us. And this little jump over here, this is like a meta jump. It's the same kind of ask, and people were saying, oh, you have a bug. Well, don't just go and solve the bug, write a test and solve the bug, right? You would write a test and then you would solve the bug. And the test actually just provides you with a little analysis, such that it's very cheap for you to go and find out whether or not you're on the right track. And it's that feedback loop that apparently at the beginning it looks more costly, because now I have to go and stop what I'm doing at this level of abstraction and go a little build a meta tool that for what I need. But then in the long run, because of the feedback loop that this tool offers, right, because of this loop over here, the cost actually decreases overall. And the same thing we're applying now, but for pretty much any kind of reasoning we want to do about our systems. So we are building a technology for this, and this technology that I'm showing you right here is called Glamorous Toolkit. Glamorous Toolkit is we call it a moldable development environment. And the core idea is that we want to make it incredibly inexpensive for people to create these kinds of custom tools so that we can enable this flow. So in order for moldable development to possibly work, the molding of the tool has to be pretty much almost zero. And if it's too large, then all of a sudden it's no longer profitable, or it's difficult to make that jump at least. So the whole point of Glamorous Toolkit is to push the boundary and see how far can we go along this path. And then of course now we're using, when we started with Glamorous Toolkit, we started from this idea of reading, because that's the one thing that occupies that occupies the largest chunk of development time, and yet most people don't talk about it. So talking about reading, talking about how developers read code, that's pretty much never a subject of conversation. And we think that it has to be, because it doesn't make sense from a business perspective to spend the largest chunk of the budget on a single activity nobody really talks about, because if somebody doesn't talk about it, it's not explicit. If it's not explicit, it has never been optimized. So, but we are, of course, Glamorous Toolkit itself is the first case study or large case study that has been built according to this methodology, pretty much from the ground up. So whenever we are building anything with Glamorous Toolkit, is a validation for, or we want it to be a validation for, the idea of moldable development. At the same time, the work we do as a company, we're a consulting company, and we work with either with legacy systems or with helping startups, for example, discover domains faster using the same tools and techniques. And those projects too are also or at least we aim for those projects to also be a validation for these projects. So I showed here a couple of situations where we'd use this tooling to reason about an existing system. But what about this idea of, what happens when we start constructing a system? So let's take here a case. I have here a playground. And if I go to this path over here, and if I go to API GitHub.com /fincom, fincom is our organization, I'll basically get a response back with all sorts of information on it. So it's like a JSON. And I'm going to do exactly what I've done before. I will simply take, because I have a JSON over here, and I don't know how to read it with text. I will just parse that one. So now I have a better idea of what I get in front of me. And I can see over here things like public members URL is over here. I can see this, the avatar URL is over there. And somewhere there should be some public repos, for example. We have those, and there should be somewhere some repos URL. I don't see it right now, but it's somewhere here. Where is it? I don't see it. Okay, here's the URL issues, here's the members, and so on. Okay, so from here, this is like the entry point, and we can basically go and navigate. We can go and navigate. Oh, here, this repos URL. Oh, fine. We can go and navigate from here, right? This is an API. And I don't know the schema of this API. I don't have a lot of information. I just know this one. But I also see, okay, look, I have this URL over there, which means that I could go and follow it. Now, if I have that information, I can actually start to go and document my understanding of that API. But instead of scribbling down on a piece of paper or writing a wiki page, I can actually document it in code. So let's see how it looks like when we have done that one. So here I take this dictionary that I just created over there. And because this dictionary already said I represent the details about this organization, it kind of begged to be made a first class entity. So that's exactly what we're doing here. We just created here a GH organization. We said new, and then I said, okay, let's put the raw data in this one. And then it's basically, this is like a wrapper. It's a first class entity wrapper on top of that dictionary. So now I have this organization over there. And so here is the raw data. That's exactly the same dictionary that we saw before. But now, because I can see, look here, there was this okay, here is repos URL. Because of this one, I can now actually manufacture a query that goes over to this, follows this URL over there, and gives me a list of those repositories. So now all of a sudden, this is a custom view built for this organization, but it does nothing but summarize what I found through my manual exploration. So, which means that if I find one of these projects, for example, Toolkit, which is the main our main project, we can see here there are 183 issues. What I see over there is, okay, this is now a repo, and it's called Toolkit. I can see, okay, these are all the events or the latest events, and we can see the contributors. And okay, this is me. If I click on myself over here, I can actually go, and now I'm getting to a contributor view, and so on. So I can go and essentially navigate through this whole maze, this whole API. I can go and understand it piece by piece. And at the end of this exercise, at the end of understanding that API, I actually have a tool that documents the API. And we notice this is a class of use cases that we have, and of actually using Glamorous Toolkit as a way to go and explore APIs. And this one is essentially irrespective of the language in which you're going to build your system in. You still want to go and document your understanding of some sort of an API that you want to have an integration with. But so the question here is still, how do we do it? So how would we go from this to this kinds of views over there? So let's actually do this. So I will just say, instead of this GH organization I already have, I'll actually do the same thing, but I will call it my organization in this case, and I'll simply pass the same dictionary in. Now, it says here, well, I don't understand this class. This is now Smalltalk that I'm writing here, and it tells me I don't understand this class, so you should maybe want to create it. And if I'm creating it, it gives me an editor, which is writing inside the playground. So in writing the notebook, I'm starting to write code that actually gets, it becomes part of a system. So, okay, let's say I'm at Rebase now. So I'm going to create a package called Rebase, and I will have my organization, which is going to be a super class of object, a subclass of object. And of course, now it says, well, I don't understand raw data, so let's create that method. And I'll simply put this dictionary in a raw data instance variable, which I don't have yet. So let's define it a slot. And if I inspect that one, all of a sudden I have this. And when I inspect, I have my organization, which is just an instance. I have an object of my organization, an instance of my organization, with a raw data instance variable over there. Okay, so now the first thing maybe that I want to do is I can see if I click on the raw data over there, I get a dictionary with this view. But I actually really would like to have the raw data right here, this preview. So let's actually do that. And I'm now switching to the meta side of my organization, which gives me the class side. So this is where I can actually write code. And so here I will say, let's say I want to create a raw data for, and I'll pass a view. And so what a view here, a custom view, is defined as a method in the class of the object that I want to inspect. And so this is this method over there in the same class. And I'm going to annotate it with this pragma, that's how we call annotations in Faro. And so here I will say, okay, I want a columned list, and I want the title to be raw data. And because I want to do that, I'll say I want the items to be the raw data. And like I did before, I'll just take the associations. And I'll take a column, which is going to be called property. And the value of it, the text of it is going to be given by the key of the association. Then I want another column, which is called value. And again, the text is going to be the value of the association. If I execute that one, I have exactly what I want over here. So I have a new view. But now I want to go to this repos URL, and I want to get whatever comes from there. Now, I don't know what that is. So what I will do now is I'm just going to play a little bit over here. I'm going to open here an object playground, and I'll say, okay, raw data at repos underscore URL over there. If I execute that, I have exactly this string, which is great. And I'm going to do exactly what I've done before. I took this one, and I said that, and I say get. And if I execute this, I should get another response. And in this case, this response is an array, right? It's an array of things over there. So let's quickly just do this. I'm going to go in here, and I'm going to create another one and say, I'm going to create another repos for this. And I'm going to say, I want to return a view. And in this case, it's just going to be a list in this case. Repositories. And I'm going to say, okay, I want the items. And the items are going to be exactly this. Whatever I wrote here, that's what I want the items to be. And maybe here we don't just want that, but we also want to instantiate it like this. So very simple. And so now I have a new repository thing. And then of course, each of these is going to be an array of dictionaries, and then each dictionary is going to be something new. And what am I going to do with this? Well, every one of these dictionary is a repository. What am I doing with the repository? A dictionary that represents a repository. I'm going to make a first class out of it. And once I'm going to make the first class out of it, I can go and query it. I can go and visualize it the way I want. And because the flow is already made such that I can link things next to each other, that's exactly what I will do right here. So this is the exact process that we go pretty much every time we have to go and understand any new piece of data. And it doesn't matter what kind of data that is. It doesn't matter whether it comes from files, whether it comes from APIs, whether it comes from databases. We're going to pretty much use exactly the same flow. And what's interesting here, and it took a while for us to figure this out. What was interesting was that when we realized that by doing this, it's the flow that pushes us to create first-class entities. So we no longer talk about designing, because of principles. We don't talk about cohesion and coupling, which are of course important, principles. But it's so hard to explain those things to people. Instead, we simply, because there is an incentive offered by the tool, we will end up creating interesting first-class objects that actually represent our understanding of the domain. And we do this with pretty much everything. So here's a more interesting example. In this case, this is a visualization which is called squarified tree maps, and we implemented a paper or the algorithm coming from a paper which is called squarified tree maps, implemented or written about 2 years ago. And so this is the case. This is the poster child case that is featured in the paper, and it's interesting because right, you have a paper, right, and the paper it just gives you an abstract understanding, but it goes for 10 pages describing how the algorithm works, why is it important, and so on. And then you have to go and implement that thing yourself. And then it's kind of hard because details there matter quite a lot, right? And it's not unusual for some things to get lost in this translation of implementation. But if you go scroll down this article a little more, you find this kind of this picture over here, which I found quite interesting. So basically, this gives you the steps that that the algorithm took for this specific case on top, which is our implementation for this specific case to implement to produce this picture. So you can see how our implementation is slightly different. You see here 4.3 is there, and in their implementation 4.3 got at the bottom. But still, it's very important to understand these little steps over here. So first step, you try to put there, 6 under another 6 over here, and then tries to put that one there, and then didn't like it, so it rejected that one and went to this path. And again, the interesting thing, the reason why this is so important is that that's exactly what was the key for us to implement the algorithm. These pictures were so important, were actually the thing that made the whole implementation cheaper to do. Now, how did we go, right? If this is so important, then why would we just want it to live in a paper first? And second one was, well, not only that, but because this picture was important, this is how we went and read through the algorithm implementation so that we can actually implement it. We actually didn't wait for the end of the algorithm to start looking at the picture. We actually implemented the pictures first. So the interesting thing here is that, right, every one of these things, so this is a successful step, this is an unsuccessful step. It's kind of similar to that one, slightly different notation over here. But the important part here is that, first of all, we have to have the notion of a step. And that's not obvious, right? If you read the algorithm, if you typically take an algorithm like that, you have functions, right? You do not see a step as being a first-class entity. But because we needed to visualize it, now the step is a first-class entity. And so this is actually how it looks like when you are actually doing this computation. So you get the preview of it, but then you also get this kind of visualization in the inspector. You can also sometimes see it like this because it's cheaper to see, like you can see other kinds of information over there, or simply just a list, or like that, so it's cheaper to see what the actual path was that was taken in the end. And so this is the, right, and then here if I go back to, for example, one of these, right, and if I click on that, I actually go and I can see there's an entity over here in this list, which is a step. And this is not an obvious thing. And we get to understand, to see these kinds of entities simply because we want to go and visualize it. And we find this pattern over and over again that happens, that sometimes we are able to rewrite a test, we implement the functionality, we make the test green, but then we find that because we can't visualize it, we have to go and redo the structure of the, for example, of the algorithm or whatever the implementation is, only to find that we don't have to actually go and change the assertions that much, but we have to refactor the internals of the algorithms just because we want to make it explicit. And there's a very interesting part here that it looks like with moldable development, we are exercising something that is orthogonal. We're exercising design in an orthogonal way to what a classic test-driven development, for example, flow would exercise. So what we are seeing here is that we're using these kinds of views as a set of operators. So the environment becomes changed from just, oh, let's go and analyze some legacy Ruby on Rails system to now let's see how do I document the way I implement an algorithm in a paper. And so we have it's the environment that has these interesting combinable operators, and those we can take into all sorts of extremes. So for example, here we have a case where we have this is a typical, so Glamorous Toolkit is implementing Pharo, which is a Smalltalk language. And this is a typical case for teaching the Smalltalk syntax. This is the method by which people say that the Smalltalk syntax fits on a postcard over here. And it has been used in books to describe how the syntax works. But of course, if it's live in your environment, you can also do things like this. So here on the left-hand side, we have the different constructs of the language. And then on the right-hand side, we have the code. And then, for example, here I have a comment. So let's say if I transform this comment into a string, then now it will find it as a string, but not as a comment. So you can do these kinds of super interesting interactive, you can create these interactive experiences, and notice how this experience too is tailored to a specific goal or to a specific task. So what we are, but we can take it further. So if I take the same thing And I'm looking now at a class. This is some class, but it's called GTCS picture, and there's a method over there. And what I will do now is I will inspect this method. And in this method, there is a tab which is called syntax explanation. And what's interesting is that I will take exactly that explanation that I have over there, and now I'm transforming it into a teaching tool that is applicable on whatever the person that wants to be taught on chooses. So we took exactly the same effort of explanation, but because we transformed it into an operator, now it's applicable in all sorts of different contexts. And of course, we can do this with all sorts of other languages. So here is an explanation of a React component, of a structure of a React component. We took this one actually from the React website as an explanation, and now you can see it here live. And it works under the same conditions. So this only to say that this idea of moldable development has far-reaching consequences that go well beyond the way we read and also start to affect the way we create, or at least the way we form mental models about anything that we are doing. And this is what happens when we are starting to look, and the question here is, as we are able to do all of these different views, and we project all of these different apparent or seemingly distinct spaces under the same experience, it should follow that those spaces are probably not that distinct. Because if they would be so distinct, then we would not be easily doable or combinable with the same kind of simple operators. And so that's our current focus. The question is, how far can we go? How far does this go? Because we saw, okay, the way we read, but then we started to read all sorts of systems. But then it was not just about reading; it was also about how do I create my own system. But then it goes possibly into the way we can teach using these kinds of custom-made experiences. And so when you look at this, as I was saying, look at the kind of spaces, for example, IDEs, that's where people are going to program, right? And then we have notebooks, which are like some sort of programming happens there, but they're not quite as debuggable, right? But it's interesting because people can formulate narratives. But then we have knowledge management where you have only narratives, but they are not really programmable. And then you have API tools, some other breed, which again deal with knowledge, because at the end of the day, any computation encodes knowledge. They appear to be completely distinct. And just like how we decompose what happened inside an IDE, the question we wanted to ask ourselves, and that's what we've done for the last couple of years, was what happens if these ones come together? And what happens when we turn these tools upside down? And instead of seeing tools as being distinct or things that we go to, what if tools come to us? What if we decompose those tools into operators that we can start combining in many, many different ways, exactly when we want to do it? So if I go to the most basic type of experience that I can have, and that's a single note, I can say, well, this is a note. And I can also say, well, in this case, this is actually some sort of a markdown. And this is about moldable development, for example. And now I get here a link to a page. And if I click on that one, I get exactly the same thing that I had in the previous thing. So instead of seeing inspectors now, I'm seeing a page, which happens to be in the same database as when I wrote this. And now I have a link to that page. Now, of course, this page actually knows what the underlying structure is. So I can anytime switch to an inspector of it. I can see the snippets of it. I can go and interact with its internal side at any given moment, but I can also keep up and just be where I want to be. So in its simplest form, right, the development environment can simply be just a note-taking tool. And of course, this one has also backlinks, just like you would expect from any other respectable wiki implementation. But then we can go a step further. So here, for example, we have a page in which here we have a textual snippet. And here, these are also textual snippets. But here we don't have it. This is a visual snippet. In this case, this is a wordly map. And this wordly map is an interactive snippet. I can go and create new labels if I want to. I can go and delete them. And what's interesting over here is that this is a language. It's a way of depicting language using depicting knowledge using a language that is non-textual. So I can see, for example, here I have a link to software assessment. If I click on that one, I can see, okay, this is about software assessment, is the activity of understanding the situation and so on. But when I look at the references over here, I can see, oh, look at that. There is actually a link that comes from here to there. So we now have we're representing, when we talk about, having an integrated experience for pretty much anything we want to express around software, it should follow that it cannot be language specific. So these snippets over here, the reason why this is interesting, beside the fact that it's an interesting tool for representing or for decomposing problems, it's interesting also from a software engineering perspective, because now I have some custom-made non-visual, non-textual language. And in fact, over here, if I click on that one, I can actually create a link coming from this little node over there to the software assessment page, and that's the reason why we are seeing this backlink there. So we have a knowledge base now, which is composed out of knowledge extract or captured using multiple different representations, and some of them can be textual, some of them not. And then, of course, some of these parts we can simply transform the way to take this one and now use it for programming is to just simply have here a kind of a snippet that is able to offer other types of like, for example, programming abilities. Like a Faro snippet would give me a ability to program against Faro. A JavaScript one would give me that. So talking about this, here's a page which shows that we can actually. So here we're going to do the same kind of thing that we've done before. We're going to get a yarn.lock. Yarn is a way to describe, again, dependencies. And if I'm inspecting this one, I can see, okay, this is a yarn file. But let's say I want to go and do the same that I've done before. I just want to go and visualize those dependencies. The thing is, however, that I don't have these dependencies. I don't have a parser for yarn available in Faro, but I found one here in yarn package log file in Node.js. There's a module which is available. So now I'm just going to open here a JavaScript snippet, and I'm going to pass this log file content. I'm going to pass it to there, and if I execute that one now, I'm going to get back a string with the JSON. So now what do I do? Well, I'm going to do exactly the same thing I've done before, and I'm going to have a JSON over there. I'm going to maybe massage it a little bit over here, and then eventually I will go and visualize it. So now I have that kind of a visualization. So the interesting thing here is that we've just took this thing that looked like a note and transformed it into a programmable notebook. And then what's even more interesting here is that we can go from here and explore even more. So this page over here, actually, if I maximize this, I will see that this is actually a part of a book. And this is actually the way with which we document Glamorous Toolkit itself. So now we have a book over there. And there's an interesting snippet over here which basically says this one. So every snippet here has a variable, an implicit variable, which is called this snippet, with which we can actually go and introspect into the database, so the actual object that is behind this snippet over there. So now by doing this, we're going to get, oh, this is a database, give me all the pages. I have 96 pages here, which means that I can now manipulate this as I would do with any other thing. So when I write a little code over here, I can see, look at that. There's this chart of connections between different entities. And so different pages in my knowledge base. Now, of course, that is not really useful because everything is going to be related to the table of contents over here. So instead, I just want to take this table of contents out. And when I'm going to do it again, I'm going to see a much more interesting picture here. And then, of course, I can go and take this one and then I apply and I maybe highlight things that are more interesting. So, for example, this is Lepiter. That's the component that adds this kind of knowledge management and notebook ability into Glamorous Toolkit. And I can see, okay, these are the pages that relate to that. And so here's the interesting thing, because this is not just a thing, because there's an actual object that stands behind it. I can actually click on it and I go and edit, I continue to edit. So not only like the whole environment is already made to be queryable by design, simply by combining, just offering a little operator. And because I already have all this ability of inspection and so on, and the flow already exists, this is not a new space. It's exactly the same space, but now it's applied to what people would consider knowledge management. So if we take a step back, the whole idea of moldable development is that we need custom tools to relate to software, and that the development experience of the future, or ideally of the present, should be system specific, or even case specific. That is, if I go from one system to another, I should literally see different things, and I should feel different things. And this one implies new skills. This is not something that would just happen overnight. What we've learned is that it takes a while to go in and learn these skills. And there are at least two kinds of skills that we have identified. One is a stakeholder, and that's the one that knows how to formulate the question and do something, make an actual decision when it comes to the when they get information. And then you have the facilitator. That's the one that goes in and builds a custom tool whenever a specific question happens. Now, of these two, this is the cheapest one and the simplest one to train. But the differentiator comes when you're training or changing the way the stakeholder creates or thinks about software. Because it's kind of like, it's very similar to how DevOps, for example, transform things. So DevOps came with new technology, it came with new skills, but the actual impact in reality comes when the organization changes how it deals with software, right? So, and integrate it into the actual, if it's a business, into the business model, for example. And so these kinds of skills are actually interestingly cross-cutting. I'm not going to go into this, but it's suffice to say that we think that these are essential skills for software development. And what we have learned is that the implication of the word goes significantly beyond what is considered to be software development, because it is easy to, or it's absolutely pragmatic today. We're showing that we can integrate spaces that appear to be very, very distinct, very separated, and create experiences that are very, very fluent. And by doing that, we can explain the inside of software systems in a way that normal humans can reason about. And we think this is an important problem, because increasingly software is not just computation, but it describes the rules by which our society works, and it makes decisions that affect everybody about how about the actual running of the society. So in a way, software becomes both law and order at the same time. We can't leave it remain a black box. We have to make it easy for everybody to participate and to have a say in how the future of our world would work. Thank you.
Well, thanks a lot, Tudor. A virtual applause. So the way we can start this discussion is maybe let Alex and Oscar to comment to what they've seen and relate to their experiences in this field.
Yeah, thank you very much. Yep, so I can start. It's fine with you, Oscar. So yeah, so thank you very much, Doru, for this excellent, amazing presentation. I've been a Faro user for decades, and recently jumping to GT, and this is really amazing. I mean, some of the things that really mind blowing, I think. And yes, so Oscar, maybe you.
Sure. So maybe I'll jump in to ask a question. So I've also been a user of Smalltalk and Faro for years, and I've been following the developments of GT for a couple of years now, and it's very interesting to see the evolution, how GT has broken out of this Smalltalk inside a window view with a completely new kind of user interface framework, so that we're using native Windows. But not only that, the tools are starting to look very different from the classical kind of tools that we see in Faro, which are pretty similar to what we had in the Smalltalk 80 environments. So the question that I have for you, Doro, is, so I see a lot of very interesting advances with these moldable environment, especially how to better support developers in asking questions about the code that they have. But I think you hinted, especially at the very end of your talk, that this collaboration is also very important. And even though GT goes way beyond what we've known from Smalltalk, we're still trapped in this single image model of how Smalltalk works. And if we really want to go to the next step towards better support for collaboration between developers and other stakeholders, we need something a little bit better. So my experience so far with GT, the only workaround that I've had, which kind of works, but in a very ugly way, is to work through Zoom and remotely share your access to somebody's image. And it's super clunky. My question is, do you have some ideas of where you can go with this to better support collaborative development, collaboration between developers, or collaboration between the developer and a user or stakeholder?
Yeah, we do. So let's start. First, what Glamorous Toolkit is right now, or at any given point in time until now, is the best understanding we have, or not the best understanding, the best ability we had to implement our ideas at the time. The other thing we notice is that we actually could not, like, people are asking us, for example, what's going to be the roadmap for the next 2 years? And we literally had no idea. So if I look back, for the last 2 years, we had no idea that it's so easy to, that notebooks and knowledge management, we had a hint about notebooks. We did understand knowledge management, but we didn't see it as being, we still saw those things as being completely separate. We saw them as necessarily having to be completely a different experience, because that's what we somehow were trained to do. But then what happened over the last year, we took this, we had a notebook, and we had a way to describe these interesting interactive documents, but they were still two separate engines. And then with this introduction of this Levitor, what we noticed was that the implementation didn't grow. It's pretty much the same kind of, a similar amount of code, but the ability of, like, the kinds of use cases that we can cover now are just have exploded maybe an order of magnitude. And so there's a whole deal of underlying or hidden assumptions there that we have to go and unearth. So now back to your question. If I go, we spent a bit of time over the last few years going through the talks or the works that happened in the 60s and the 70s, and it's really interesting how far away we derailed, like, as an industry, from the vision that people had, 50 years ago about what computation should be, right? So the whole idea of personal computing, for example, was that it was supposed to be personal, right? In other words, right, you should go and experience a computation the way it fits you, and it should not be the same necessarily as everybody else's. And then where are we today? We're in a place where we readily go to where other billions of people go, and having same experiences as every other, as all other ones have. And then we wonder why these tools and interactions have the dramatic impact on the society that apparently they had. And that's because the free will is basically taken out of the equation. So we started from the perspective of a single developer working on a single problem. And now we're going our way up. And during this journey, we have to say, well, what is not interesting? What from what exists today is not useful? What from what exists, what assumptions are actually hindering rather than helping? So when it comes to, when we know that interaction, right, that whenever it comes to anything about computation requires feedback. We know that when two people want to communicate with one another, they need to have some sort of feedback. So yeah, we do know that, of course, going to a Zoom, another medium, is not as interesting as the interaction can be. But there are other places, right? So we didn't invent, for example, knowledge management. There's lots of work done in knowledge management. And we can learn from there and say, well, how do you get that kind of interesting behavior and integrate with everything else that happens here? And that's basically, that's a research question that we have in front of us. On the other hand, we have the engineering reality. So how much of it can we actually go and implement? Now, on the reality, on the engineering side of things, the way we see it is that, well, Glamorous Toolkit started as a Smalltalk system, because that was the cheapest way for us to go and explore. But what happens now with the, for example, with the knowledge management is that part of the logic goes out of that Smalltalk system. And if we consider the interaction, for example, with JavaScript or with Python, there's not even Smalltalk on the other side. So Glamorous Toolkit eventually has to become just a client-side technology. And then even more interesting is not the implementation, because why does it necessarily have to be Smalltalk? It doesn't have to necessarily be Smalltalk. So how do we take, once it's just a client, and why not try, or why not doing it in another, or porting these ideas to other similar systems or other kinds of clients, other ways of delivering things? Will this have the same kind of ability to introspect on yourself and change the system as it runs? Probably not. But if you have a distinction, for example, between a client and a server, and the objects that you're actually inspecting relying on the server, then that's the thing that has to change. And then the client can continue to, it doesn't have to necessarily change. So we don't necessarily have the client to be super reflective as we have in the case of a Smalltalk system. That's on the practical side. So I think we have to distinguish between this. So our main focus until now was to say, how far do we need to go, or how far can we go on this idea of having an integrated experience, but that doesn't simply do a union and everything that we know, because that's also not interesting. But on the practical side, what I'm very, very convinced of is this. The environment, now we are showing that the environment can be a language. And 40 years ago, we used to have a handful of languages. Now we have a handful of tens of thousands of languages. And so what I'm sure of is that once this space is going to be taken seriously, and we're gonna break free of these experiences from the previous century in development, for example, we're going to see many other kinds of languages with which people will decompose experiences. And I think that's going to be the exciting part.
Yeah. I have a question. So I jump into the Smalltalk words, especially with Faro, because of I'm fascinated by the fact that everything is an object in Smalltalk, or nearly everything, and this is something that really attracted me. And with GT, you usually go one step further by saying that you have object, but then also now in GT an object is able to represent itself. You can even search in object. You can redefine the scope of a search operation within an object, and this is really one step further. But on the other hand, I feel, as it was with Smalltalk and Faro and GT, that there is always a dominance of the source code first. All the examples you started with source code. It's not like among the dozens of thousands of objects you have living right now in your image, you still created a new object by evaluating some code snippet. And for code snippet, you have plenty. For source code, you have plenty of operations: search, replace, copy and paste, and syntax highlighting. But for object, I feel there are still things, like object orientation. I do believe that there is still a lot of room to explore there. Such as why I cannot search object, or why I cannot replace object, or clone object in a very easy way. I know that there is ways to do it, but it's still not something that is really part of the natural way of programming. And I'm wondering, what do you think about that? Do you think it can still push object orientation further?
Yeah, it's hard to say further, right? If you go back to for example, what the Xerox, the Palo Alto team was thinking about objects, this idea of an object knowing how to represent itself. That's as long as the object exists, right? It's just the question is, what survived in the implementation. And then from there, right, it was stripped down, and then people just took over inheritance and some sort of polymorphism. And that's what people call object orientation. But it has nothing to do with objects. Those are just something to do with classes, right? But so from the very beginning, the whole idea of objects was that it was supposed to be something encapsulated. It knows how to, it knows about itself, but it also knows how to view itself. And then, of course, like it got embodied into a VM, a single VM, a Smalltalk VM. But then again, like if you look back into, when the whole discussion about the internet was happening, and the work around Smalltalk in the 70s were happening, like there was always a conversation about objects being, like a VM is an object. And so, or objects just traverse somewhere, right? And the whole internet is made out of objects. So if you look, for example, at Erlang, right, it got that idea and then push it further along that line. And I think this is super exciting. And right, it's very easy for objects to just, I'll just go to do stuff, and in parallel to everything else, and I'll have a gazillion objects doing stuff, and somehow they will be able to collaborate with one another. And I definitely think that that's absolutely the direction in which we have to go. And so there's also this more recent conversation about functional programming versus object orientation, and it's very interesting to observe that one, and then observe how people, for example, are saying, oh, look, I have this I have a REPL over here, right, and I can just call this function, I can see a result. Guess what they're seeing, right? They're seeing an object there. It's not called an object, it's just called some result. But like, it doesn't matter how we are capturing these species. At the end of the day, that's exactly what computation is. It's like it's going to be something that happens in the computer, and then we will need some sort of translator to reach our sensors. That's it. And we cannot take the view out of the equation. And until now, we have considered the view to be static. So even in a Smalltalk system, if I go from a system A to system B, I will see exactly the same thing. So when I take two screenshots and I stay like 1 meter away from them, it's hard, I can't distinguish between them. They look exactly the same. While in our image, right, we have, 1,500 different views. And when you start combining them in many different ways, you'll get millions of possible screenshots. That's what we have to get to. Now imagine this at the scale of the internet. That's what I think we have to get to. And that's what I think personal computing eventually is.
We're starting to get some questions on the chat. Maybe I'll start going through. So Joao asked, what do you think is the greatest obstacle to the adoption of a Glamorous Toolkit?
It's again, like it's so easy to start talking about a tool, but our goal is to change how people relate to the inside of software systems. We've built Glamorous Toolkit because it's a vehicle for us to understand how far we should go, but it's also we need something to give something practical to people to work with it. And of course, on the practicality side, like people will adopt whatever is practical within some short amount of time, unfortunately, because that's how investments tend to happen. People always ask what's in it. And so until that will happen, then the adoption will only be as good as the answers that you can get to, what kind of concrete problem can you solve. And so this is why when we think about, Glamorous Toolkit, we're saying, well, we're not going to necessarily compete directly with an IDE, although it is an IDE, but we're going to compete with, we're going to offer things that you cannot get in other places. So if you want to reason about your architecture, then you're going to start there. And whoever wants to reason about architecture, then, well, it's a very concrete case to start from. And another kind of case that we see today is, and the reason, one of the main motivations for implementing Lepiter, so the knowledge management part, is documenting. How do you document a system in a systematic, testable, easy to maintain, and evolvable way, right? There's no solution for that today. So Lepiter you can have a Lepiter database live inside your whatever system you have, and you will view it with the Lepiter client, which right now resides in Glamorous Toolkit. So that's another practical solution. So what is the largest obstacle here is education. the main problem we see in practice is that people spend the largest chunk of their budget on trying to figure systems out. And there was, for example, a similar point was raised in a previous session about debuggability, except that the problem is larger than debugging. It's like how should business reason about what needs to happen next? How do you get a conversation, a domain-driven design kind of conversation happen with a business expert or with a domain expert about that relates to the inside of the system? That's not necessarily expressed as, it's not a debugging problem. It's literally just showing something. So showing the inside or having a conversation where the inside of the system is in the room when the conversation happens. What we see today are decisions being made on beliefs, on pictures drawn by hand about what people believe the system to be. That's the main obstacle. That's the thing that we have to change. And once we change that, once people will start to realize that reading is actually the enemy, and not in general, like it's a good thing to read, but not when it comes to reasoning about code, then people will start demanding or looking for those kinds of alternative situations. And so what we want to do with Glamorous Toolkit is start that conversation, show that there is a conversation to be had there, and start from there. But that's for me, the biggest obstacle really is the fact that this budget, this 50% or more that people talk, when people try to or spend today to reason about systems, does not appear on any management budget sheet. So that's the biggest obstacle.
So in short, the key thing is to convince people that development is not just about coding, but about effective decision-making.
Yeah, and today we think it's about managing knowledge. Like everything inside a system is about manipulating, understanding, relating to knowledge to support some sort of decisions.
Another question that we had, which kind of links in with my question earlier, is if there are any plans to have GTB an IDE for the web or for web development. And there was also some discussions in the chat about synergies with Seaside and also about the idea of a federated wiki using Lepeter. Do you have any thoughts on these directions?
Yeah, so with Glamorous Toolkit is a platform with which one creates system-specific or even case-specific experiences. So we are starting to show a number of those kinds of use cases. But what we want, and when this will succeed, if the community that we are building around Glamorous Toolkit will take it over and start creating these kinds of instantiations. So new set of operators that are specific to some subsets of domains that then afterwards people can start combining, like with Lego bricks. And the interesting thing there is that it's not an all or nothing type of thing, right? Like the whole thing simply can start with just one more view and another one more view and another one. And then when you have enough of those, right, then the combination of them is, explodes. So if you go back, for example, to the demo with GitHub, I'll show very quickly. So if I go to, where was it? Yeah, so to here, right, if I see, okay, these are all the repositories, and I go to a repository, this is one repository, and I will see this is one contributor, and then I will see all the events that I can see from there. It's one kind of a statement. But so the event appears here, right? But if I'm looking the other way around and I say, well, here's an organization and I have all the events. And now I have a completely different statement. The views that I use are the same. This list of events is exactly the same, whether or not, right? This now I'm applying it to this whole thing. And before I applied it to just an individual developer. So what's interesting here is that now with the environment, I can formulate two sentences with the same effort, just by doing the way I combine these views. And what we find is the more of these you have, the kinds of sentences that you can express is that it simply explodes. So there's a very interesting incentive to create the next one, right? And the more there is, the more views there are in a certain area, the more interesting is to create a new one, right? You have more and more incentive. So what we are hoping to get is to get to enough body of such views and extensions so that it becomes ever more interesting for new people to start creating in new kinds of customizations, thereby basically creating a snowball effect. So that's the way we look at it. But absolutely, web development is an interesting area, is an important area, and we want to consolidate on that. So talking about that, this is a case of a JavaScript a JavaScript snippet over here, but it's a JavaScript snippet in which, let's say here, in which I have a debugger statement, right? And if I execute that, what happens here is that I get a debugger over here, and this debugger is a debugger over JavaScript, right? So I can actually execute this further, and it still goes into JavaScript.
No, we only see one window. I think you must have opened a new window.
Okay, I will share the whole screen.
Yeah.
So here we have a debugger over JavaScript.
Mm-hmm.
But what's interesting is that what's this debugger? How is this implemented? Well, in fact, this debugger knows is a normal debugger, the one that starts in Faro, and it knows here. Oh, look at that! I have a language link promise over here, and I'm waiting for value. And because I know this, I will propose to you another debugger. And this is now in the same infrastructure, right? So the debugger is also moldable. And this was also interesting. Like we started this whole idea of the moldable debugger started in 2013 or so with the work of Andrei Kish, who did the PhD at the University of Bern with Oscar and me. But at that time, we didn't know it will work with other languages. So we had some way of, and we just learned, this is basically, we just learned a couple of months ago that it does work nicely. Also when we have other languages on the stack. So that was a very interesting surprise for us. So literally, like this is the having or embodying or incorporating the debugger for JavaScript in this case is nothing but just a debugger that simply listens to our normal debugger that allows us to plug other kinds of debuggers. And then of course here, if I execute further, I will still get the result at the end. Oops. So that's how it works. So yeah, we do think that this area of the web is important. Now, federated wiki is probably slightly different. I think it's a highly exciting project. There's a lot to learn about that, and I think it does not take the attention it should. It addresses a different problem than we do. There's a lot of technical similarities, but the problem is interesting in itself. So if here, for example, it's kind of like in a classic wiki problem, in a classic wiki, you'll have, it's focused on documenting the current consensus. The whole idea of federated wikis is to say, how do we enable a dialogue? How do we enable two competing views on the world to coexist at the same time and be comparable? And I think that's an exciting thing. And it's complementary to the kinds of things that we're seeing here. And I do believe that there's a great deal of opportunity in merging some of these directions.
There's another question in the chat, which was about if there are other examples of the moldable development. It was partially or maybe completely answered that there's something for Emacs, which is probably the other environment which comes to mind by looking at it. That is also fully adjustable. You are living inside the list machine, but do you know any other?
So I think there's a distinction here to be made between a moldable environment and moldable development. And distinction is indeed like Emacs was the first, let's say, the first one to show that there is a great deal of power in changing ones, like by living inside that environment, you can change the environment to fit your needs. It kind of was created in parallel to Smalltalk, right? So both of those have a similar idea. It's true that, for example, with Emacs, you'll have many plugins available. The question to ask, and that's when the difference is between the tool and the practice, is how many of those plugins change over time? And ideally, how many of those plugins change over the course of a day? So as you were seeing with, for example, with the case of GitHub, I was just creating two different plugins, two new views while working on a problem. It means that two new plugins appeared while within the space of 15 minutes. And that's the differentiator. That's what moldable development is. So at the end, it's not so important as to, we should distinguish clearly between extensible and moldable. And moldable means extensible while you're working as a way to improve the way you work. Emacs does have the potential to do that, but it didn't in practice. And the other thing with Emacs is that it has a specific, it's very elegant as long as everything looks like text. There are things that you can add, like, pictures, you can have visuals now in more modern Emacs, and I think this is absolutely interesting and people should go and pursue that. But it should also be considered that those kinds of, those views, they introduce a new kind of an artifact that are not manipulatable under the same, they are not part of the same abstraction as the text editor is. There's like foreign things that come in there. Important, useful, but there's a difference there. But yeah, Emacs is something to learn from, absolutely. I think we don't see a lot of moldable, we see a lot of malleable, extensible systems today. So for example, if you look at something like VS Code, or the initial selling point of Eclipse was that it was extensible, and indeed people created, for example, with VS Code, you have tens of thousands of extensions, which is already better than before, and yet it's not practical, and we have to make it practical enough to address a specific problem with a specific tool that after we throw away. And it's more economically viable, it's more profitable to do it that way than to do it without the custom tool. That's the Rubicon that people have to cross. As long as I have to use the same plugin that everybody, like 10,000 more people are using, I'm not there yet. It's still just an extensible system. So that's basically how I see it. It remains to be seen whether we're correct.
The other question is a bit more technical. When the Think GT will be out of beta?
Yeah, when it's ready. But it's like Glamorous Toolkit is usable the way it is, and we are using it in production case study or situations already. It is already usable by pretty much any standard out there. It just does not have the kinds of things that we think are important. For example, let's say smooth navigation between any parts of a system, or a stronger kind of an undo that cross-cuts a bit the system. Those, I think, are necessary to call something a non-beta, and until we get those, we'll probably be in some sort of a beta. But people are using it already, so, and we don't get a lot of inflow of open issues. So it's usable, but it's just not. We are the ones that are not satisfied yet.
So you mentioned before, right, that it doesn't have to be Faro, it doesn't have to be Smalltalk. So if you could, what would you pick? What are the key features or the main things that the environment/language has to support for this to be usable?
Look, implementing an inspector in VS Code is really not that difficult. It's just people don't do it because they're not asking the question. So, like even that one would be probably sufficient to start from.
But isn't it the major difference between VS Code and what you've shown is that basically, like, you are really living inside your environment. Everything is an object. Everything you can easily inspect, and the environment from the very beginning was meant to be completely amenable, right?
Yeah. So as I said,
editors, except for Emacs, let's say, doesn't give you that.
Yeah, you probably get. So this, could we have discovered this one in other mediums, would have been really difficult. So could we have formulated what we can formulate now in terms of what we think is important, and have the case studies behind this to show why moldable development is a new kind of a development that adds a new feedback loop in development, and because of that has all sorts of, for example, business implications. We would have not been able to do it if we were not already having these kinds of properties inside. That being said, can we work, now that we know what we want to build, can we work around the limitations that exist, for example, in the JavaScript virtual machine? And we probably can. So why do I say that we can? Well, if you look, for example, at a, like what happens with a Docker image, like basically the whole industry went away from Smalltalk and now and also from Lisp, and now they are trying very hard to somehow recreate it clumsily with some sort of like props basically. And so could we build or use similar kinds of props to deploy these ideas in current technologies? Yeah, I'm sure we can. I think that there's a great deal that you can go to, like a great deal of, we can go to a great length to incorporate these ideas in, for example, in a JavaScript-based space. It's not going to be exactly the same, but a great deal of practicality can be added there. If that answers the question.
There's a question for you in the chat.
So it says here, is Rawsal going to be available in Glamorous Toolkit? Rawsal is a visualization library that Alex is implementing in Faro.
But Alex, maybe you want to say something more?
So Rawsal, I think, at some point has reached a kind of plateau in terms of what it was, what it was designed for, and we are definitely exploring new venue, new reason where Rawsal can be also profitable, and GT is surely one platform that looks really interesting.
So we were actually doing, so Alex is visiting Bern for a few months. He's almost at the end of his sabbatical. But one of the things that we decided to look at with some students is exactly this question. The reason it's interesting is because with the original versions of Mondrian and Rawsal, you have this barrier, you have this nice DSL for building different kinds of visualizations, and Rawsal is adding all these other kinds of visual tools. But you hit a boundary at some point because you can't just compose anything. And what's new in GT as opposed to Faro is that you have this single rendering tree. So every kind of visual or graphical or user interaction element is at the same level. And that means that suddenly things that you couldn't do before in Rawsal or Mondrian become possible. So you can have Mondrians containing Rawsals, containing windows or Lepeters or anything. It's all composable. So this is the thing that's mind-blowing for me. And we were doing some experiments with a couple of students, master's and bachelor students this semester. I think it looks kind of interesting, but nothing's ready for prime time.
Yeah.
Maybe I can.
Oh, sorry. Go
on. Just a general question about, like, if someone wants to learn GT, like what do you recommend? So programmers do not really like to change their habits, right? And teaching a new tool for programming is very hard. I mean, as it was discussed in the previous session. But learning a new programming environment is even harder. Like, so what is the strategy you recommend for learning GT? For, let's say, a C programmer or a Java programmer.
So the way we recommend people to learn is to start from a problem that they care about. So the whole idea of moldable development is that context is the most important thing, and you need to make the tools fit your context. And so which also means that until you have a context, or until you formulate a context, no, all tools would just look like any other tool. But the real magic, like, and there's this, it's an incredible thing, like so just like if I go back to this problem over here, or where we were just showing just this thing here. So we have this algorithm that we had to implement, and we have this view, but it was not sufficient until we could produce this picture. If you do not have that problem, if you do not have that picture that you want to create, you simply will. It's very difficult. It's pretty much impossible to project what does it mean when that picture is available to you. And there's like it's an adrenaline rush that is undescribable without that. So start from a context, something a very, very concrete context. And then the other thing here is that we now are shipping, with Glamorous Toolkit, we're shipping a book, which starts to have a number of tutorials over here, including, for example, I don't know, if you're into Java and you want to go and investigate this. So this is the book made out of Lepeter pages. So there's a presentation over here about dealing or analyzing Java, and so that's basically how you would do that. So start from a problem, and then go and read the book, and then join us on our Discord to have a conversation with the rest of the community. That's what I would say. These are practical things.
Yeah.
Maybe there was one point that Oscar made about the one rendering tree. So what do I mean? What do we mean by that? So let's find a case. For example, here, right? We have some piece of text over here. We have some visualization embedded in some snippet over here that is actually produced by this specification. So the question, for example, is what kind of shortcuts are available here, right? So if I now do Control-Shift-Click here, is this visible?
Yes.
Right. What we are seeing here is, right, we're seeing the rendering tree on the right-hand side, which is kind of, you can think of it like the DOM in case of on the web, except that here, this is a single word in there, right? There, it's there. So, but, and if I double click on that, I can see the preview here on the right, right? So I can say, like, this is a word. And then if I go back to the editor, like this is the whole editor, I can see here the editor element over there. What's interesting here is that the editor, like this is when these views start to make sense or start to pay off. So there's this editor element over here, which has shortcuts. You know, the shortcuts have, I say, okay, here are the shortcuts that are available at this moment, right? So if I say, let's say that I want to say, oh, how do I indent, for example? I can say, okay, this is meta plus right bracket. And how is this implemented? And if I now double click on that one, I'll say, okay, this is a shortcut that also knows the source code. So now I can go to the source code. And of course, if I click on that, I actually go to see the source code and in the context of a browser. Yeah. So now we just went from not knowing anything and in a few clicks, basically discovering where in the source code should we look. And of course, if I now zoom in here, I can now see the source code as if I, read it from the, like with this idea, this more classic way of here's the index of the different static parts, and then here's how the editor looks like. But then at the same time, is like this, have this flow in which we have discovered it. But the other part that is maybe more also worth mentioning here is what happens when we start clicking on something like here. So this is now a visual thing. And notice how this part over here is also part of the same tree. There's no difference here. And that's what I mentioned with respect to other environments, right? So for example, it's not just everything is text, or it's just literally everything in this whole scene is representable using the same visual abstraction. And this gives us a whole great deal of flexibility and opportunity that is otherwise significantly more expensive to get.
So now when you have all these kind of views, and as you said, like that the ideal or what distinguishes this from the other things is that you actually make views as you go, right? As you are solving your problems, you are making new tools, or maybe not just views, it could be tools. But can you see the way how they can be shared? Because at some point I don't want to do the same thing as someone else did. I don't want to create my own GH organization and stuff like that. But yet have them extensible, right? Maybe I would like to have a little bit from here, because you don't want to end up with having 10,000 tools for exploring GitHub, right? That would be too much. What is the concept behind all of it?
So right now we are sharing things via Git. Everything becomes code is publishable via Git. So a model would be like, for example, a GH organization. In our case, is an entity in the model, and that will become a class that is actually even now. So if you download Glamorous Toolkit, you can redo the same. You can redo the same. The same browser of Git without actually implementing it yourself. So that one is already shared. But sometimes the model comes from somewhere. Let's say somebody has implemented an API browser, but I don't like all the views. and I want to enrich those with other views. So in this case, I will be packaging my views in a separate place that simply, and I will load it on top of the other model, and then all of a sudden my inspectors will be aware of it. In the future, though, there's already underlying things. So the same infrastructure that we have to talk with Python or JavaScript, we can also use to talk with Pharo, and in the future there will be other kinds of bindings to other kinds of runtimes. And what we want is these views to actually come to us from the server, not necessarily from the client. We already have implementations for that, and we'll probably be focusing quite a bit in the near future on that. So this whole idea is that, yes, objects should know how to present themselves, and wherever the objects come from, they should have the opportunity to influence how we see them, because that's the documentation. So these are the directions that we see.
Yeah.
Yeah, so I was wondering, like, at some point you would like to really compose them and stack objects, and you know how to compose objects, but maybe is there any sort of like a fundamentally new way how you would like to see the composition of these things, how the behavior of certain things can be reused or connect together, or is there something in the space of like a pure object orientation that should have been explored? Or during your presentation, what kind of always get back to was I saw a demo from David Ungar when he was showing self at some point, right, and showing how they managed, there was this the scene that they had these planets, moving, and they could just put them on one another, and, and it made this kind of a ad hoc composition without touching any code, whatsoever. Yeah. And so I was wondering if there is something to be learned and used for this thing.
Oh, I'm sure there is. I'm sure there is. And so, yeah, like we live today in a Smalltalk environment, but the key is our objects, right? Not classes. So there's anything that happens in that space is very exciting, and it's very interesting. I would just like to see this idea of, for example, one of the interesting things here is that views are a way of, so mirrors, for example, are very interesting. So how do you make views to be safe for the objects that they work with, right? So we want an object to come, or we have an object, but how do I make the view not pollute? Or, for example, if I take the view from somewhere else and I run it on my machine, how do I prevent it from doing something harmful for me, right? And those are interesting. Those are interesting things, and the way you would, so anything that goes in that direction I think is interesting. And the other thing is, how do you get, so the notion of context, having the notion of context be explicitly available in a system, or like as a first class entity, I think this is a very important part, and I think we're just at the beginning of that. And I'm not talking about aspects, maybe part of like a little bit of, what the kind of work that has been done around context as a programming language construct. I think that is an important part as well. And I think there's a great deal of like when you have, imagine a world where you have millions of views. And as I said, right, the way we filter, the only way to define context today is I take an object and I see, okay, what class are you in? And then there is this, so it's a very rudimentary filtering mechanism. So out of 1 million views, maybe a dozen views will be relevant at any given moment in time. But what if I have a class with hundreds of views? How do I nicely or interestingly understand the context from which I'm coming from, so that the tool does the filtering or interesting filtering for me, so that it doesn't show me everything that is needed. So I also think that this part of thing is interesting. And the other thing is, yes, indeed, like anything that does anything towards liveliness is very interesting. Also to be said here is that these views that we have so far, they are very much focused on the reading part, right? And I think there's exciting work that happens on the defining computation through some sort of interaction with the system. I do think that that's a very hard problem. So the reason we're focusing on the reading is that this is the most unexplored part, right? So far, most visual approaches, if you look at model-driven engineering, or if you look at visual languages, very exciting, especially with the visual languages, but they always tie the visual explanation to the way you're describing or to the way you're creating computation. And what we see is that there's a much larger need to read than there is to create or to build computation. But that doesn't mean that this other part is not meaningful. I think it certainly is meaningful. And so having, like what's an interesting way? How do you do a Babel of visual languages and that interact with objects in interesting ways? And in a way that you can reason about what happens in the different languages. I think that's also an open question, and I think it's also an interesting area that should be explored.
Absolutely. Well, I think we have about 2 more minutes, so I don't know if you guys want to do some last words, some last comments about this work.
2 minutes is short to
Go for it, Alex.
To praise all the good thing of GT, but I heard like many. So I'm not really talking about an experience, but I heard like many people using GT, and I've seen many people using GT, and it's really astonishing, like the feeling that people have, and especially like I've seen some people using GT in Faro for some time, and then going back to industry, doing something else, some JavaScript, Java / whatever. And they really have this background in their mind, and this is something that is really fantastic to see, I think. And yeah, maybe it's one of the strength of all these moldable ideas, that it really changed the perception of the world, and something that it is really remarkable.
I know that my own experience getting to actually program with Smalltalk and Squeak and Faro really influenced the way I looked at non-live environments like Java. So I got very frustrated and said, I want the debugger to work in a different way. I want to be able to dive into the live system. And that really colored me. But now, since using GT, despite many warts and issues and problems, now when I go to other programming languages, I just suffer even more. It's just, why can't this be more like GT?
Yes, that is impressive.
So we want people to enjoy GT and then really suffer when they go back to their old programming environments, so that so that they can see the light.
All right, well, that's a nice message to end the discussion. Thanks a lot, guys. And in 10 minutes, we shall have another session. So stay in if you're interested, and otherwise, thank you and bye.
Thank you very much. Bye-bye.